Okay, using the calculator for the chi-squared goodness of fit. Actually, it's chi-squared. I should put a D in there. Chi-squared goodness of fit. Okay, and you can use the symbol for chi for this one. If you have a single categorical variable, you want to see if the results follow a set of expected proportions, use a goodness of fit test. Okay, so an example of that would be, let's say that we have a game. There's a game that follows a published set of probabilities for the possible results. You question whether the probabilities are actually true. The null hypothesis is that the proportions follow the published probabilities. The alternative is that at least one is different. So let's take a look at a possible game. Let's say the payoff is minus $10, $0, $5, and $100. So there's a 30% probability that you lose $10, 20% that you break even, 40% that you gain $5, and a 10% probability you gain $100. Now, obviously, whoever's running this game is going to lose a lot of money on it, and we can talk about that with expected value. But right now, I just threw some numbers out there, and let's say that we ran this 100 times. And we got these observed results. 35 times we lost $10, 21 times we broke even, 41 times we gained $5, and 3 times we gained $100. Our expected is just 100 times each of these probabilities. So 100 times 0.3 is 30, 100 times 0.2 is 20, 100 times 0.4 is 40, 100 times 0.1 is 10, and we add these all up and we get a 100. So now what we want to do is use the calculator to get our chi-squared. Well, if we have a TI-84, we would go to second list. Actually, it's easier to go to stat edit. And if I go to the first list, I can type in my observed values. So 35, 21, 41, and 3. In the second column, actually, I accidentally put that in L2. So remember, that is an L2. In L3, we're going to put 30, 20, 40, and 10. So our L2 has our observed. Normally we do this in L1, L2. It makes your life a little bit easier, but I'll show you in case you do have it in a different list. This makes sense. So I have my L2 is my observed. My L3 is my expected. Well, what if I could have the calculator do my expecteds by putting in L1, and this is what we did last time, 0.3, 0.2, 0.1. Oh, I got to put this in the top. Well, I could put the probabilities in L1, multiply L1 times 100 and get L3. So that if the proportions are a little bit weird or the n is weird, that might work a little bit nicer. So now, in order to get our chi-squared, we just go to stat, test, goodness of fit. So I come down, chi-squared, goodness of fit. Notice the symbol. My observed is my L2, so second L2, which is already there, L3, second L3. Now I have 4 categories. Since I have 4 categories, my degrees of freedom is 4 minus 3, or 4 minus 1, which is 3. So now I can calculate. The probability of this happened by chance, given that the probabilities do follow, is 0.12. That's not far out of the realm of possibility. So we'd say there's not enough evidence to say that there is a difference, or that that any of the probabilities are different. We'll say this last column does give us a 4.9 chi-squared contribution. So if it was significant, we would say that this 4.9, since it's so large, would be the reason why there's a difference.